Thank you. So now that I look a little more like an engineer, let's talk into ACI Policy Model. So this gets into a lot of Jason's question. So the idea of the ACI Policy Model is, again, very simple idea of what groups connect to what groups. We take a group and call it group 1. Take a group, we call it group 2. Take a group, we call it group 3. Now, you tell me that these connect. Let's say that's your application. Whatever makes up your application, you've got your 3 groups, you've got the connectivity between. Then you probably need a user. So we'll have Joe user, because I'm all about me. And Joe user connects. Now, the other thing I need to make an application network profile to look at the way in which we work with our policy model is the policy itself. It's not just about connectivity, it's about policy. So between each one of these connections, you put in some policy. And what we use is an object called a policy contract. The reason we call it a contract is it's the same as any other contract. It's an agreement of how interaction is going to happen. Same as your contract with your employer. You get benefits, a paycheck, and whatever, and you do whatever, whatever, whatever. If you're me, you do nothing except babble. So we take groups, connect to other groups, we put in policy contracts. Now the policy contract is the first interesting piece. When you break out a contract, this one's probably pretty complex because these are users outside my data center. In many cases, this one might be connect these 2 groups, allow anything to talk. In some cases, maybe not, but it could be. So you can put in a policy contract that just says any communication, which is fine. The contracts themselves are reusable objects, so you create them once, reuse them, modify them, change them as you need. This contract is probably going to be a lot more complex. When you think about users connecting into maybe a web tier, now you're probably going to need to do things like firewall the traffic. If you have 1 million users hitting 100 web servers, you're probably going to need to load balance that traffic. You may need to do SSL offload. You may need to do other layer 4 through 7 services. These are all things that we consider policy. So within this contract, I have inbound and outbound rules. And it's important to note inbound and outbound rules. When you think of an access control list on a switch, if I put an access control list on a switch that says disallow HTTP on port 2, what have I just done? It's a very tough question. Disallow HTTP on port 2, what have I just done?
Disallowed HTTP on port 2.
I've disallowed HTTP on port 2, right?
Trick question.
But it's inbound and outbound, right? I don't have any way with an access control list to say this can come in, but only this can go out. So when you think about what a firewall can do, firewall can say, I'll allow this in, but that out. So think about connecting to a web server. You might allow HTTP and HTTPS in, but only HTTPS connections out. That way they have to secure a connection before you're sending data back out. Is that a fair statement? So we do inbound and outbound rules. You can apply quality of service within these, so user experience. We can apply several other pieces of what you might want to do. We can do packet redirects, we can do marking, we can do DSCP tags, these types of things. So redirect, we can do copies of packets if you need to send it off to another device. And then we can do a service graph. Service graph is probably the key to what we do with ACI. We are all about policy automation. If you think of ACI as a policy automation engine, you've got your mind in the right place. The service graph is very interesting. Most places, when you talk about services, we talk about service stitching or service chaining. We use what we call service graph. It's a little different. Service stitching or chaining is great if I need to go through a firewall first, then to a load balancer, then to another group. That makes sense? What if I need to take mobile traffic one way, non-mobile traffic another way? I need to do this, handle this type of compliance with this and this type of compliance with the rest. Now I get into more complex graphs of how those service devices get interweaved. Is that fair enough? So our model is built to allow for a graph. Whatever you need to do with those services, however they need to be stitched, you build this graph. So when you take this idea, the very simple one, if this is my 3-tier web app and we did web, app, and DB, what you end up with is a service graph that starts, maybe this is my firewall pool, and this is my load balancer pool. Come in, come out. Once I insert this contract here and apply this application network profile, we go down, we configure anything that needs to happen on the routers and switches, put this stuff in place. We go to we can go to those firewalls and load balancers and insert the new rules that you've defined for what that policy requires for that traffic connectivity. And all of this is automatically deployed. So when we do that, there's 3 ways we integrate with layer 4 through 7 devices. And again, they can be virtual or physical. We can use platforms like Imbrain, which is a layer 4 through 7 service platform. When we do that, there's really 3 ways in which we can interact with service devices. So the first way is what I like to call it the it's already there, leave it alone, don't touch it way. So you can say, my firewall's already configured, another team handles that, I don't want my network device touching it, redirect the traffic to it, let it do its job. Fair enough? The second way is what we call a device package. And a device package is, again, a piece of the way in which we're going with a very open way in which we interact with other devices. A device package is a simple concept. It's basically got 2 sides to it. You tell me the name of the features you want to expose from your device, your firewall, your load balancer, your SSL offload. And then you tell me the Python scripts to be able to implement those on the device. So this can go through the API or the CLI or however your device can handle that interaction. With that device package, it plugs into our APIC controller, or Application Policy Infrastructure Controller, and when you deploy this down, we'll go run those rules and implement those rules onto your firewall and load balancer. Now, those device packages can be written by the vendor. They don't need any type of contract with Cisco. So if a company builds a new firewall tomorrow and wants to be able to integrate with ACI, they can develop their own device package and give it to us. If a services partner or a customer wants to build these on their own, they can build them and import them into the APIC and then control those devices. We don't go do full config management of firewalls and load balancers and other devices. That's either handled through an upper level system or it's handled manually or however you do it today. What we will do is instantiate the rules when you instantiate the application network profile, which greatly simplifies the idea of applying layer 4 through 7 services to traffic, because an application does not get delivered without those things. Is that fair? Any questions so far on that? No. I'm getting a stare down from Ethan, so I'm wondering.
No, go ahead.
All right. Anytime, let me know. I occasionally can get technical if you need me to. So we take that device package. Now the next level of integration is what we're working on with several vendors, and that is OpFlex. So OpFlex is a control protocol for other devices. OpFlex is basically the way in which our APIC controller talks to the devices like the Nexus 9000 and other devices. So we have layer 4 through 7 vendors who are currently implementing OpFlex. What OpFlex allows us to do is tell that device the intended state. This is what I want you to do. This is what I want you to look like. It's a uniform way to define what I want that layer 4 through 7 device to do and allow it to implement the changes. I don't have to know the deep level configuration on a given vendor's device. It has to know how to interpret OpFlex into its own commands. Right? So it's the idea of Promissory, which Mike Dvorkin talks about quite a bit. Promissory is developed by a gentleman named Mark Burgess, who runs CF Engine. The idea is most network management systems today are what we call the imperative model of computing. Anyone ever had a micromanager? Micromanager doesn't tell you go get this done. Micromanager tells you go get this done and do it this, and I need it back in 5 minutes. Right? A leader tells you what you need to go do, trusts you to do what you need to do, and you go do your job. You implement whatever they said from a policy and intended state, however you implement it. Is that fair? Promissory works in that fashion. Network management systems today, the reason most of us have had huge issues with them is that they're designed, they have to know every little low-level command of every device that they're controlling. You change your firmware and things start to break, right? You got to keep everything in sync, and so maybe I can't upgrade my switch firmware until they upgrade that network management system or whatever it is, because they have to know everything about that device, everything about its current state. With Promissory, we trust the device. We say, hey, this is what I need you to do, implement it, and if you have a non-compliance event, send me an alert or a fault, and then we can either do automated remediation or alert you or the admin to it. Does that all make sense?
What's been the uptake on OpFlex from the industry? Now you got partners that are using it, I get that, but there's also a movement to see broader adoption with OpFlex as a policy language. How's that gone?
So we are having pretty good success with it so far. So the companies that are partnered with us on the protocol that I'm aware of right now are IBM, Plexi, Mitacora. I believe there's one other that I'm missing.
Didn't F5 announce something, or? What F5 announced? Or future integration.
Right, and yeah, I believe, and don't quote me on this, but I believe F5 and Citrix have plans for it, right? So there are some other people working on it. But the idea is, and the beauty for, let's say F5 and Citrix, and use those as examples. I'm not saying they're implementing OpFlex because I don't remember if they are or not. But the beauty is, with many protocols, you dumb down to lowest common denominator features, right? Many protocols will have to take each device and make them equal because it only knows how to configure X, Y, and Z. Think about OpenStack kind of does this. If you look at OpenStack, it makes all of the hardware underneath kind of look equal based on whatever capabilities are in that release of the software. Does that make sense? With OpFlex, Citrix and F5 are able to differentiate what they can instantiate based on what their own hardware products can differentiate on. So that is the beauty of OpFlex and the reason we are going down that path. Adoption will take time. Any open source product takes time. Any open source protocol takes time. But we are working very hard with that and other open source projects around this.
Is the IETF picking it up at all? I mean, the draft is out there, but is there any interest within the standards body to keep driving it forward?
There's interest within the standards body to keep driving it forward. How far along it is and where it is, I'd have to go back and check for a current update, and I can get you that and let you know where we are and where we stand with that. I don't have it off the top of my head. In fact, do you mind pinging Mike Cohen on that?
But OpFlex is working today in ACI mode, right?
Yeah, we use it. It's
right.
what we use internally for how we work.
So in theory, I guess, you know, there's been some overlap or people talking about OVSDB versus OpFlex. So if APIC was removed, would it be possible to actually do your own development to communicate via OpFlex to, let's say, Nexus 9K?
Yes, so there are works in the open source community to basically implement our policy model using OpFlex. You would think Open Daylight project with the group policy plugin that they're working on. OpenStack, which we're working with OpenStack on Neutron policy plugins. And then OVS, Open vSwitch, implemented via OpFlex. So those are in various stages of progression along the way. And again, open source is committee driven or community and committee driven, so it is never a fast process. Right?
But see, we're just talking about two different things, right? And I hear the whole OpFlex versus OVSDB thing quite often. And I think the beauty that Joe's mentioning with something like OpFlex is that there's really no competition there in my mind. Like, it's not like those protocols compete in any way because they don't do the same thing. And that's a good thing, to be honest. Right? You've got a specific protocol like OVSDB that works on the concepts of all of the various artifacts within the schema, and it implements those things because at the end of the day, something has to get implemented. But you've got something like OpFlex, which says, okay, you've got this particular configuration protocol. You might have netconf over here. Let's implement the normalizers at the edge and sort of push that down to the devices that need to make that configuration change. Is that accurate?
It's accurate. And when you look at using this policy model in a open fashion, if the device underneath, let's say the switch underneath, supports OVSDB, OpFlex can translate to OVSDB and utilize whatever feature set of that is to implement policy. So OpFlex is designed as kind of, I look at it as an abstraction layer for how the policy gets implemented. Yep. Whatever the device underneath is able of implementing, it's able to translate down to that so that you can implement it on whatever the capabilities are of the device.
Yeah, they're not competing.
No. I do not look at them competing. It was originally like Cisco's competing with OpenFlow with OpFlex. That is not at all what it's trying to do either. It can use OpenFlow as a tool to implement routes, right? That's what it's designed to do, is whatever the capabilities are underneath.
But you're no longer using those protocols to and from, let's say, a controller, right? Between the controller and the endpoint is OpFlex, and you can do whatever you want on the device to actually get that policy deployed.
Right. And it's the idea of giving you policy consistency across whatever devices you have underneath. So one of the things we're doing with ACI is Cisco is making a very big push into the open source community and into being an open platform. And this is, I think, a big shift from a lot of the ways in which we've developed a lot of our products in the past. So you're seeing some big changes from a big company because the market and the world has changed.
Well, how do you deal with criticisms that it's open, but you're really kind of telling people what they have to do, right? Because you're like, well, this is the Cisco way of doing it, so you should do that.
Well, you use a sparkly bat, I get stabby.
Right. Okay. Well, there you go.
The criticism is always going to be, as Cisco, we're always going to take criticism on we're pushing something new, right? We're the big bad market share leader, we're pushing something new, so we'll take that criticism. But if you look at what Cisco has done in the past, open source in the network world and open protocols in the network world are a new thing. It used to be standards, and that's how you were open, right? That way you could interoperate with other devices, right? Cisco's always been a big push of standards. If you look at things like LLDP, it came from CDP. Many of the routing protocols that are out there came from original Cisco protocols, right? And we push into the standards body and then adhere to the standards once they're standards. So open source is just another way of doing that, and we are working hard to do that. that. I think there's going to be some mindshare shift that has to happen over time, but we're going to work hard to get that mindshare shift, and we're going to probably take some criticism in the process. Just not from you. Okay, so we good on what we're implementing here and how this works and what we're doing as far as how ACI works in a Cisco fashion, correct? All right. The other beauty of this, the service chaining and the automated deployment of those rules, whether it's with a device package or with OpFlex, is if you were to go into any data center you work in and you were to do a show config on the firewall, I guarantee you would see the ghost of applications past. You would have firewall rules for things that no longer exist in the data center, because it's really, really scary to go pull back at a firewall rule and, oh, by the way, the person that implemented them originally is gone and we don't know what that rule is doing there. So we leave them. And you have a bunch of extraneous junk in your firewall. Eventually you run out of amount of rules that you can use because TCAM is expensive and that's what they get written into. Eventually you get auditing problems and other issues with how these things get set up. So what we do is, if you're using a device package or if you're using OpFlex and you decommission this application, we pull those rules back out of those devices as well. They were placed in on an application basis, they're visible on an application basis, we pull them back out of that device, freeing up those resources. We pull things back out of TCAM on the switch, we do the rest. When an application network profile is implemented, it automates the provisioning of the switches underneath. So it goes down, it pushes down wherever that application touches. If this is a group of virtual machines, we'll create a port group on that hypervisor, or if you're using Microsoft, we'll go through SCVM and create a VLAN. And now they'll attach, and we'll be able to have the policy pushed where they actually live. Today, when we think about things like virtual machine migration, we typically have to have each port that virtual machine could ever, each switch port that virtual machine could ever hit, configured identically. That way it has the appropriate policy wherever that VM might go. Is that fair? With this, we can do that if you want, or we can see that virtual machine migration triggered and move the policy where it needs to go, remove it from the device it no longer needs to be on. So now you can keep much tighter security and policy requirements that stay fluid while you have that workload anywhere type environment. Again, all automated, ties into the hypervisors. Today we tie into VMware through their API. We also have, I forget the term we use, but it's non-supported ties into the Microsoft hypervisor with the support coming. So you can use it for test purposes today. And then we'll have KVM and Zen Linux hypervisors OVS integration as well.
Non-supported as in non-supported from the Microsoft side, or from the Cisco's just not yet fully tested it outside?
We haven't fully QA'd it to a point where TAC will support you on it.
Gotcha.
It implements, it works, we can show it,
Yeah,
but TAC's not going to help you if it
not
doesn't
quite
work.
quite there yet.
Yeah, it's a QA thing. Simply a QA thing.
So regarding the OVS support, I was curious, on day one I seem to remember there being an integration plan on some sort of pamphlet. I believe it was through OpenStack, so it required that you push policy north and then have that plugin kind of reach back around to instantiate tunnels and stuff like that. Is there any updates on that?
So run me through that question one more time. I just want to make sure I'm...
And this is just, I mean, this is obviously old information back in like November, but back then I believe the way that you guys integrated with OVS was through OpenStack. So you'd push your policies up, and then OpenStack would use the OVS plugin or the ML2 driver and reach back around and do the whole tunnel instantiation into ACI.
Oh, yes, agreed. So that is the day one, and there is some progress that goes on beyond that. Now, on the OVS or Microsoft Hypervisor or any of those things, even without integration into those products, or even without supported integration, we can still work with them. It's all about how you get into this group, right? So this, I think, really gets more into Jason's question. How do I put something in a group becomes very important. So if we look at how we identify in a group, yes, we abstract this out so that you have these groupings and the rest, but we still have to tie into your existing network and into your existing application stack, and we don't want to change any of that stuff. So you can get in the group using a lot of different things. We can use virtual or physical port. You can get into the group using a VLAN or VXLAN tag. You can get into the group using a subnet. And there's probably something I'm forgetting, but those are the main ones today. A port group will do it, but a port group on VMware is just an 802.1q tag does anyway, so same thing. When we look at doing this, we'll actually today instantiate the port group on VMware. The VM admin would just select that NIC, select that port group. They would see that distributed virtual switch there and run with it. This takes me the first step. What we have coming down the road is being able to get into that group based on some very more interesting things. Things like DNS and DNS wildcard, right? So my star.web could be a group. Things like DHCP pools and VM attributes, other things to get you into that group. The beauty of the grouping is that if I'm in this group for policy and connectivity, and I'm in this group based on my virtual port, if you change my IP address or my VLAN, I still have the same policy. If you look at the way a server works today, a server works in a very funny fashion because we really destroyed the OSI model. And we never thought that things were going to be moving around the data center, so on and so forth. So the server's IP address is how we forward traffic to it. Think of it like your mailing address at home. If you change a server's IP address to a new subnet, you just changed everything about that server to the network and to the layer 4 through 7 devices. It's as if I went home and I moved to a new apartment, therefore I get a new mailing address, and I then got a new education, a new name, a new job, and to most people's benefit, a new personality. Right? That's how a server works on the network today. Here, as long as you didn't use VLAN, as long as you didn't use subnet to get into this group as the identifier, you can change your IP address and nothing changes about your policy or connectivity. You could take an ACI network and you could put one huge /16 subnet across the entire network and still group policy in different fashions. If you had that fun problem where subnetting always fun, right? If you had that fun problem where your web tier scaled further than you expected when you first set out the subnet, and so now you don't have any IP addresses left in that subnet, and now you've got a series of really bad options for how you fix this problem that you run into. Here, all we would have to do is add a new subnet to that web tier, and it gets its consistent policy and connectivity. You have two subnets sitting here. You can have one subnet across all of them. You can have multiple subnets in a single group. Does this make sense?
Can I go back actually a few minutes to OpFlex real quick? Just either way I'm going to ask the question, I guess. But,
Too bad. I'm asking.
But we talked about the non-competing facts on like OpenFlow and whatnot. Totally get it. So I guess within Cisco's solution, it's OpFlex delivering the policy, and how is that instantiated on the device? Is it hypothetically using NX API, or is it something more native with an OpFlex?
So when you move to ACI, it's a complete operating system upgrade. We completely revamped NXOS. NXOS was designed from the ground up to be used by a human for a CLI, right? So NX API is basically an exposure of CLI commands and what the switch can do from a human fashion. With the operating system on ACI, we rewrote the entire OS from the ground up. So basically a Nexus 9000 and ACI mode's operating system is an object-oriented programming model. Every object has configurable attributes and is exposed up through our object model. So the whole operating system has been shifted, and what we have sitting on there is we call it a policy engine, a PE. Basically, that policy engine is the interpreter for OpFlex and then defines how it gets configured on that switch. So if the firmware is different on switch 1 from switch 2, that policy engine knows how to make that same intended state translate into its current capabilities.
So now is that policy engine part of the open source project?
Is that policy engine part of the open source project? On
the device itself?
There are pieces of that will be part of the project.
The reason I ask is, I think it's a really minor point. This is why there could be co-opetition, right, with other protocols, because you're not using OVSDB, you're not using OpenFlow, you're not using any existing protocol. It's part of the OpFlex framework that you're deploying an engine on the device. And if other vendors do that, they no longer need other protocols that have been used in the past. So
right. So the idea would be over time you could have that policy engine part of the project, and then a vendor could implement it. Right. If they don't implement it and they implement OVS, OVSDB, and OpenFlow, then OpFlex can utilize that.
Right. Okay.
So this becomes the AMP. Who in the room has worked with Cisco UCS? Cisco UCS. I'm a big fan. I was a convert from my being an HP Blade engineer. When you look at Cisco UCS, the beauty of Cisco UCS is the stateless nature of the way in which it operates. You have a service profile. You define what you want a piece of hardware to look like and do, and that service profile then automates the deployment. First rule of presenting: turn off all stupid pop-ups, and I failed. So when you look at that service profile, it's a logical description of what you want a server to do. You apply it to the server takes on those characteristics. If that server catches fire, you pull it out, hopefully hit it with a fire extinguisher, put a new blade in, apply the profile. 4 minutes later, you're back up and running, same service. The network, nothing else knows that it's changed. This is a service profile on steroids. Mike Dvorkin, like I said, our chief scientist and co-founder, was the gentleman who designed the model behind UCS. and the way in which UCS operates and the fact that it's API driven way before everyone had API driven hardware. This is the same idea. We take a logical description, we apply it down. Any more questions on the logical policy model and how we work? Or now you want to talk about networking?
I've got one loose question. Yep. You take the language of the network, you take the language of the application. I can understand ACI abstracting a lot of the things, like, kind of VXLAN segments and stuff internally. But where does everything meet up when it comes to managing IP space? So obviously IP addresses got to live on VMs, you've got to live on hosts. How does ACI manage that? Is there like a central repository, a database on board, or is it still, we manage that as network guys?
So we do not manage the IP addressing of your server environment. We are working on integration with systems that do that, so IPAM systems.
Okay.
But we do not do that. We're not trying to boil the ocean with what our product does, right? We don't want to change how you operate your application or your server. Okay. We want to be the networking piece of it. So we'll take the subnet and move a packet from point A to point B, but we're not going to manage the IP addresses. We can integrate with those systems, and we are working with several partners that will come down the road.
Okay.
Yeah, I was going to ask, before you dive to the networking component, workflow, what's the expected workflow of using ACI in terms of, let's say, if you have just, let's say, sysadmin, network admin, those two, and if we assume sysadmin is doing apps and compute and network is doing, or ACI is doing network, what does that workflow look like in terms of spinning up a new app?
In terms of spinning up a new app within ACI, so we have a very tight role-based access control system that'll tie into your Radius, TACACS, or LDAP. Within that, it very much depends on how you want to utilize the system. What you would typically have is whoever is your layer 4 through 7 services people will build these service graphs, and then they're reusable objects by the network team. They say that's the service graph when you have something connect from the outside in. The network team will configure the majority of this stuff. Then you can give your application owners and developers visibility into whatever piece of it you want. Let them see the ANP, so that the application network profile, so that they have visibility into the same tools that you have, but they can't dig in and change these things because it's not something that they do on a day-to-day basis.
Yeah, part of the question motivation for it was around, like, it's great being able to spin up new policy and then extract that and take it off when the app is decommissioned. But like, how does ACI know when the app is decommissioned, I guess, to be able to go back in if you're not deploying it like through ACI? Does that make sense?
So it does make sense, but if you decommission the app and you don't specifically tell our controller that you decommission the app, it'll stay provisioned. You still have to go delete that application network profile.
Okay.